Today we have a panel discussion on energy engineers' role in safe and sustainable world. On the occasion of birthday of Bharat Ratna Sir Visvesvaraya, just I want to tell a brief about Sir Visvesvaraya. As an engineer and administrator, the kind of work which Sir Visvesvaraya has done will stand as an inspiration to many more generations to come. To point few of his works, he was instrumental in designing and patenting of a system of automatic wear floodgates, architect of Krishnarajasagar Dam in Mysuru, and he has designed a flood protection system, Ghat Road construction at Tirumala Hills, played a key role in developing a system to protect Visakhapatnam Port Trust from sea erosion. He also commissioned several new railway lines in Mysore state. He had designed and carried out the waterworks for the municipality, development of block system which would prevent the waste flow of water in dams. And 1955, he was awarded Independent India's greatest honor, the Bharat Ratna, for his impeccable work in the field of engineering and education. Just about IIP, I want to just briefly, I want to mention that IIP was established in 1971 with headquarters at Madras, Chennai. IIP was formed to cater the needs of practicing engineers in India in line with and association with the then Institution of Plant Engineers UK and Japan Institute of Plant Engineers. IIP was also recognized as a non-profit organization by Government of India. IIP is dedicated to improving the effectiveness, utilization, and productivity with continuous improvement, performance, quality of plant and machinery in industrial manufacturing processes and services across all sectors. You can other members, others new to IIP can log on to IIP website and go through the details of IIP. As today's panel discussion, we have classified some subtopics into four subtopics: safety, health, and welfare of public, and commitment to improving the environment to enhance the quality of life, comply with the principle of sustainable development. And other panelists will be talking about improve the understanding of technology in appropriate application of and potential consequences, maintain and improve technical competence, and to undertake technological tasks, adopt standards in their engineering practice. So now I would like to introduce the panelists to the audience. We have engineer M. Ganesh with us. Mr. Ganesh is an electrical engineer having more than 40 years of experience. He is a qualified MTech from IIT Kharagpur and BTech from REC Warangal. He holds the DMS from Bombay University. He worked in Crompton Greaves and in Gulf countries as GM project manager in electrical projects and also as a quality engineer and trainer. He is approved faculty by NITS, BIS, New Delhi for IS and ISO training in QMS, energy, environment management system, OHMS. He is presently BIS, an external auditor and trainer for industries and institutes. Warm welcome to Engineer M. Ganesh. And we have Mr. Eric Ho from Singapore. Thanks for joining, Mr. Eric. He is Vice President, Global Standard Solutions, Singapore, a regional standards and certification consulting firm. Mr. Eric is widely recognized for his work over a decade in promoting American Petroleum Institute standards and certification initiatives across Southeast Asia. Eric has about 25 years of industry experience from manufacturing, testing, and calibration, oil and gas to standardization. Eric is an active member of American Society of Mechanical Engineers. He was two-term chairman of ASME Singapore section. In addition to his current role as a local section leader, he also serves as a ASME professional section ambassador. We have with us another eminent national panelist, Engineer Balaya Santapuram from Hyderabad. He is CEO of Trinity Energy Tech Sustainable Solutions. Mr. Balaya is a mechanical engineer, postgraduate in mechanical engineering from MTech from IIT Kanpur. He's having more than 4 decades of experience in boilers and combined heat and industrial power plants. He's a BE qualified certified energy auditor. He had worked in reputed organizations at various functional levels in the engineering companies, including Tata Consulting Engineers, Mumbai, Thermax, Babcock, Velox, Pune, Krupp Industries. Welcome, Mr. Balaya. And we have with us engineer V. Vishwanathan from Chennai. He is a corporate trainer, consultant, and author. He is a postgraduate in management and graduate engineer from University of Madras. He has served in senior level position for over 3 decades in India and Oman in organizations like TAC Limited, Reliance, L&T, and so on. He is a DC psychology certified trainer and master behavioral skills trainer. He is a project management professional and also he is a CII supply chain management professional. He has master diploma in training and certified NLP and EQ practitioner. So I think with this introduction, I would like to ask Engineer Ganesh to kickstart the panel discussion. Over to Ganesh, sir. Thank you, sir.
Okay, I'm just sharing that this on my screen. The file loading pass visits. No, this is not the one. This is where is it one? 1 second. I just holding on to sharing.
Can you put share screen? Share.
Yeah, I'm just sharing it.
Share
1 second,
screen.
because there was another was there. So sorry for the delay. We'll be just sharing that. Where is it? One engineer's role. Okay. Are you able to see the chat screen?
Yes.
Is it okay?
Yeah.
Clear?
Yes. Now it's clear. Yes.
Yeah. So, good evening to all of you and happy Engineers Day. So I'm going to do a presentation on the engineer's role in safety and sustainable world. And basically, we'll just, sort of, because the time is very limited, we are just going to go into the overview of the various topics. So I'm just giving the next slide. I just show you. Basically, the engineer's role for various disciplines, they have a different task which they have to manage. So I have tried to focus on the present day ongoing activities as well as what is the futuristic available for the present day and the young engineers in the coming years. So basically, for the safe and sustainable world, they have to have a designing innovative eco-friendly solutions, renewable energy systems, efficient resource management, safe water infrastructure and sustainable urban development, focus on reducing waste, conserving natural resources, minimizing the developing technologies that improve public health, minimizing the pollutions, ensuring long-term environmental protection and economic viability. So what are the basic key roles which we have is sustainable infrastructure. Basically, when you go into the first starting is how we can able to, whatever we manage, whether we can able to have the built up materials and construction materials, how we can able to enhance so that those materials can become sustainable. It will not take away the natural resources. So basically, we are seeing what the way is solar panels, wind turbine, hydropower, water treatment plant, and that an urban system that minimize environmental impact, green roofs, rainwater harvesting, and smart technologies for resource management. And when you go into resource, they develop implement system for recycling, waste reduction, water conservation, precision irrigation, and desalination plant, ensuring long-term availability of resources. And comes to the renewable energy, the major focus on developing integrating renewable energy source to reduce dependence on fossil fuels. And next is what we see is the collaboration. Basically, the engineers, whoever is doing it, they have to go with the other disciplined engineers so that their system can become total sustainable in terms of they work with architects, urban planners, policy makers, and professionals to promote sustainable practice in various engineering and construction projects. And when it comes to waste, so they have to ensure that the waste management system reduce, recycle, and properly dispose waste generated by industrial process and community wastewater treatment. By this, you can reduce the spread of waterborne disease and prevents environmental contamination. And hazardous items have to be ensured for a safe disposal, so it will not become a major problem for the general public. And the sustainable materials use environmental friendly recyclable materials for construction and engineering projects. And basically it can go into items called bamboo, hempcrete, reclaimed wood, recycled steel, straw, bales, board, and natural stone life cycles, which we can use. And pollution control, when it comes to pollution control, they design and implement technologies to control, reduce air, water, and land pollution. And goes to the innovation in R&D. Say innovation becomes very important in terms of bringing in new materials as per the development and the advancement which we go. So they have to see how the existing process can create a new materials for that. So the basic companies like Syngenta, seeds for farmers, for farming techniques. So that way they can have a better farmers benefit in terms of having a genetical seeds. And when you come to the role of engineers in creating a sustainable world, so I just listed out some of the key engineers who can contribute to the nation's sustainability as well as safety. So let us look into this sustainable aspect. So a transportation engineer implement initiatives such as electric vehicles, public transport, and bike infrastructure to reduce carbon emission and promote environmental friendly modes of transportation. So when you go to the agriculture engineer, so he can do it a sustainable way by means of precision farming techniques using sensors and data analytics to optimize farming practice. While vertical farming and hydroponics offer methods for high yield, low resource agriculture. They work to enhance food production through organic farming, water conservation, and efficient resource management. And next is the energy efficient engineer, who will focus mainly on the improve the energy efficiency in buildings, manufacturing process, and transportation systems. They analyze energy consumption patterns, identify areas of inefficiency, and reduce the lower operating cost. A renewable energy engineer specializes in designing and creating renewable energy system. They focus on developing technologies such as wind turbine, solar panels that use clean and renewable source of energy to create electricity. And we come to the role of engineers in creating a safe and healthy world. Environmental engineer works on various projects related to controlling water and air pollution, managing waste, and repairing environmental damage. They develop strategies and solutions to address environmental challenges and ensure compliance with the regulations to protect ecosystem and human health. So basically, we have a pollution control boards which monitors from the various major industries like cement, steel, and other power plant to monitor the various toxic flue gases coming out of the chimneys and whether it is within the limit so that it will not affect the community surrounding that plant. And when we go into the security systems, Engineers are crucial in designing secure network systems to protect against cyber security threats. Their work in cyber security safeguards critical digital infrastructure from potential attacks. Last month, India had, witnessed 20 billion transactions in the month of August through UPI. So the engineers ensure that the safety of the such transactions goes, even though there are certain cyber attacks is happening, and people without much of a knowledge get trapped into some cyber crime. So one has to be very vigilant about the usage and not revealing their personal identification to unknown strangers. And the other is in the electrical engineers use reliable quality power supply and also ensures protection systems that will protect the assets and human loss. Particularly for domestics, they use ELCB, residual circuit breaker, and numerical protection relays in substations and power plant, so that any kind of a fault can be protected, which will not affect the system. So then comes to the biomedical. These people also have an important role in the our world in terms of the technical experts create life-saving device from prosthetics and medical imaging equipment to advanced pharmaceutical production and surgical tools. They improve diagnosis, treatment, and overall quality of life. Particularly the biomedical engineers involved in the MRI, CT scanner, X-ray, ECG, ventilators for health monitoring and keeping persons for any kind of major treatments required. Then goes to the transportation safety engineers, design transportation system from vehicles to roads and air traffic control to save and more reliable by developing features like seat belts, airbags, fireproof materials, minimal impact crash test, which they do in their plant, so that they see that during in terms of any unexpected accidents, the persons inside is saved. Civil engineers play again important role in design and construction of essential infrastructure such as roads, bridges, buildings to be structurally sound and resistant to natural disasters like earthquake, floods, and hurricanes. They include creating early warning system, tsunamis, and developing infrastructure that can withstand extreme climate conditions. So now here I just show some sample for the energy efficiency. Mostly, most of the households will have devices like fridge, washing machine, air conditioners. So Bureau of Energy Efficiency has got a star rating methods in which each equipment is rated by means of how much units or power it consumes in a year. That way you can have energy higher efficiency with the minimum consumption. So this most of the households will be having it. The higher star rating gives you the high energy efficiency and lesser power consumptions. So then these are the different types of we have a renewable energy source from solar, hydro, wind power, this the tidal and biomass and geothermal. So these are the typical figures of that renewable energies. And now India has also gone into the mode of transportation, hydrogen powered train, which is just started in August 13. It's a 1200 HP hydrogen train. And this train trial runs has already been taken place last month. So this is a very good advanced way of our government looking into minimizing the environmental impact by going into the hydrogen powertrain. And this one, what you can see is the what we call how we are going to have a safe environmental system. And this is actually the Godrej Green Business Center in Hyderabad, in which the whole of this is credited as IGBC rated green building, in which most of the things you can see on the top, the green gas, solar power panels, and minimum wastage of energy. So most of the buildings have got rated by IGBC. So and also the gift building in Gujarat and Suslan Earth1 in Pune, they are also rated with IGBC Platinum LEED rated buildings. So then comes the latest one, which is you see the bridge or railway arc bridge in over the Janab River Bridge in Jammu and Kashmir. Recently, it is inaugurated by our Prime Minister, which Vande Bharat train beautifully runs over that. And this has taken so many years by the expertise of the engineers from we can call Indian Institute of Science, IITs, and for the Roorkee University. They all put their minds in bringing a very memorable technological advanced training, such a highest railway bridge train, which is running that one. And it is about 13-15 meters long. And DRDO has ensured that it's a blast proof with a 40-ton TNT and also temperature at minus 20 degrees and wind speed of 266 kilometers per hour. It can withstand, and also earthquakes, 8 earthquakes it can withstand. So such is the technological advancement. This all comes with expertise. The people have put their minds to bring India to the path of progress. So finally, I summarize the young engineers who have the immense opportunity to develop their innovative ideas to bring modern technology in multidisciplinary areas for efficient economical improvements and also for new product and process to make India achieve greater progress and self-sufficient. Thank you.
Yeah, thank you so much, sir, for your initial discussion. You have kickstarted the discussion on the very safety aspects, as well as we have covered what are the works, biomedical as biomedical engineers, agriculture engineers, transportation safety, as well as the electrical engineers, everything. And finally, with the Chenab River, how they constructed the beautiful bridges. Thank you so much. Yeah, so I would request our next panelist, Mr. Engineer Balaya Garu.
Sir, sir, Ganesh sir, stop sharing.
Yeah.
Oh, how can I?
You can make it full screen, sir.
Yeah, I'm trying to make it. Is it? Can you see that? Can you see full screen?
No, it is not coming full screen. It is still that 56% only. You have to make the last icon in the PPT. Third one.
Here in my laptop, it is showing full screen.
Yeah, you have to move that.
No,
that
no,
is not
sir. It will
sufficient.
get only zoomed, like try again with that. Yeah, that icon only.
Can you see now?
No, it
No.
is like zoomed fully. No, please trying that third icon. Please try pressing the third icon.
Yeah, this one, no?
Yeah, this one.
Yeah, I've pressed it.
But
Why is it not coming?
no, it's not coming.
While sharing, you have to do full screen sharing, and you have to click that.
Maybe you can stop sharing and again share.
Stop sharing and again share. Full screen share and make this one full screen.
Okay.
Yeah.
Can you see now?
Yeah, sir.
Yes,
Yeah, sir.
yes. Now it's okay.
Yes.
Okay, sir. Are you seeing the controls also on this one?
No, just the slides.
Slides.
Okay. I just wanted to put these controls out. How do I do that? Top computer sound.
With the arrow keys, you can change the page.
No, arrow keys you can change, sir. You can go ahead.
You have to worry
Please.
about control.
Okay. Can you hear me?
Yes,
Can you
Yeah,
hear
yeah,
me?
please.
Yeah, sir. We can hear you.
Okay. Good evening to all of you and happy Engineers Day. I thank Mr. Ganesh for covering overall, more or less all disciplines of engineering and their contribution towards safe and sustainable world. Now, I would like to focus on this understanding of technology, particularly energy efficiency and conservation aspects and its appropriate application and potential. Now, as we can see, the safe and sustainable development is essential for securing healthy future for people and planet. Engineers are the architects of safer, greener future, combining the technical skill, ethical responsibility, and visionary thinking to build solutions that ensure societal well-being now and for generations to come by minimizing environmental impact and promoting the use of renewable resources in industry and daily life. Now, if you look at the United Nations Sustainable Goals, out of all the goals, there is also one goal, which is goal number 7, which corresponds to energy. And engineers and their innovative solutions support more or less almost all United Nations Sustainable Development Goals. But particularly when we focus on this, rising energy demand and coal consumption pose challenges for the energy sector. Energy efficiency and conservation are urgent priorities for industries facing rising costs and environmental concerns. When we talk about energy conservation and efficiency, basically conservation involves using less energy through behavioral changes and practices. Basically, you are trying to avoid whether whatever your energy consumption you are taking, is it necessary for the given operation? And you are trying to see less energy for that. Whereas energy efficiency requires less energy for the same output. And both practices are crucial for extending fossil fuel supplies and minimizing environmental damage. Energy conservation and energy efficiency are two essential parts for effective energy management, for optimizing energy use in industries and ensuring safety and environmental sustainability. And what are the strategies for this energy conservation and efficiency? If you see, basically every industry requires energy in terms of in the thermal as well as electrical or both. So basically, when we talk about thermal energy, an engineer has to see that he designs a steam generation or thermic fluid heating equipment with an efficient combustion technology such as AFBC or CFBC, minimize the heat losses through outgoing flue gases through chimney by installing feed water heating economizers and combustion air preheaters. Then proper sizing of motors, pumps, and piping networks can significantly reduce energy consumption. Follow reliable O&M practices to minimize effective utilization and avoid energy wastage and leaks from the system. This is thermal. Whereas in electrical energy aspects, only 30% of electrical energy, incoming electricity, is utilized in production. Whereas energy losses occur at various points, motors, transformers, etc. So engineer needs to understand what type of electrical loads are there, and he has to optimize energy consumption. Basically, there are loads are classified as constant torque or variable torque loads. Mostly, people, when we talk about energy conservation, we talk about VFDs. So when we talk about VFDs, constant torque loads include conveyors and crushers, which save less energy with VFDs. Whereas variable torque loads such as fans, pumps are excellent candidates for VFD application, potentially saving energy based on the Cube law. So what we need, first of all, before application of VFD, without not applying blindly VFDs, but you need to understand the load pattern of the equipment and then apply. And when you apply this retrofit VFDs along with optimized belt and pulley drives, you can save energy from up to 20 to 30% you can save. Then, apart from thermal and electrical, we need to also have as a strategy, automation is a tool for energy savings. Automation can significantly enhance productivity while reducing energy consumption. Automation can lead to reduced resource consumption, including water and energy. Predictive maintenance and automation can enhance energy efficiency. Implementing IoT-based online monitoring tools allows real-time tracking of key parameters, enabling early fault detection and energy saving. Now, what are the other areas where these strategies of energy conservation and efficiency can be applied is operation and maintenance, regular equipment upgrades, and proper usage of preventive energy wastage, and renewable energy adoption. Invest in solar, wind, and other clean sources to replace fossil fuels, accelerating the transition to sustainable energy. So wherever heating, even solar heating, not only the PV cells, but there is also solar heating systems available. So wherever it is possible, you can utilize the solar systems, heating systems for process. And efficiently building design. Incorporate insulation and energy smart architecture to reduce heating and cooling needs, particularly HVAC needs, wherever possible for comfort cooling, you can evaluate the option of evaporative cooling, which involves much less power consumption compared to conventional AC system. So wherever evaporative cooling can be done, you have to incorporate that. Then call for action by engineers. Now, one of the most significant barriers to achieving the sustainable development goals is the global shortage of skilled engineers. There is a growing need to ensure that future generations of engineers are equipped with knowledge, skills, and mindset necessary to tackle global challenges. It needs to combine technical literacy, critical thinking, and social awareness with practical skills and risk evaluation. To improve the skills, understanding of technology, its appropriate application, and potential consequences is essential. And what are the key point summary is, first of all, energy conservation first, followed by energy efficiency, and efficient generation, distribution, and utilization of thermal energy as well as thermal energy. Understand the type of operating loads and energy losses and minimize to save consumption of electrical energy. Adopt system level approach and use automation as tool for energy saving. Adopt equipment maintenance through reliable maintenance practices such as condition-based monitoring and predictive PDM, predictive maintenance management. Now, these are the few areas which I thought, considering the time constraint, I thought I'd just bring it to your notice, the pointers basically. It will take a lot of time to discuss in detail all these things. And thank you very much for your attention. Thanks.
Thank you so much, sir. Within short time, you have covered energy efficiency and how to bring automation as a tool for energy efficiency. That's a very important aspect. Myself being in the energy audit and other areas, it's a very important point you have brought. Anybody want to add? Any of the panelists want to add some points on that? You can have a few points you can add, others, sir. Or during next level of discussion also, you can add certain things. Thank you so much, sir. Now I request next panelist, Mr. Viswanathan, to start his presentation.
Yes, I'll share the screen. Yeah, happy Engineers Day to all of you. And many thanks to Mr. Ganesh and the team at IIPM for giving this opportunity, especially giving it, being on the panel on the Engineers Day is really a great privilege, and many thanks. So I'll be discussing about maintaining and improving technical competence. So I'm currently more focusing on the training. So that's why I thought I'll cover on technical competence and how to improve and maintain the technical, and how to undertake technological task in a very, with a systems thinking approach. In fact, Engineer Bale was just talking about that, even in energy conservation. So when we say technical competence, what are the basic things that we need to have is the first thing is a core knowledge. We should have a mastery of the engineering principles and the domain the expertise, whatever domain, whether it is mechanical, civil, electrical, or so the domain expertise must be there, and the engineering principles, sound engineering principles, the knowledge should be there, and knowledge alone is not enough. Then the next important thing is the skills, practical skills. Today, this is one of the main factors which is lacking today. So many engineering colleges and all, when people come out, they are saying, they are all having the knowledge but not the skill. So the internship and the Prime Minister's internship scheme, in fact, addresses this gap. So practical skill is a very important thing. Hands-on experience. The engineers must have an hands-on experience with tools. And today, with the software, because there is no escaping from software, everything is now technology-driven, software-driven. So software is very much required, and more importantly, the real-world problem solving. Because engineers are here to solve the problems for the others. So problem solving focus must be there. Then the third is the adaptability, because today technology is changing at a very rapid pace. AI, ChatGPT, so many things are coming, and the engineers must be able to adapt to all these emerging technologies. And we need to evolve with the industry changes. Definitely, we can't fall behind. We have to catch up, and we need to take the lead and evolve with the industry changes. So adaptability is a very important thing. And when we talk about adaptability, I'll be discussing about a concept called Jidoka, right? Which is basically an automation with a human touch. We are evolving, but we are also integrating the human aspect. Then the next is the systems thinking. In fact, Mr. Engineer Bale was also talking about it, where we are not looking at in isolation, but we are understanding the interconnectedness and anticipating what can go wrong. If we do in one side, it should not lead to a problem in another area. So looking at the whole rather than the part is the systems thinking. So the first thing which I would like to discuss is the Jidoka. Jidoka is basically a Japanese lean manufacturing technique. And this means automation with a human touch. When we say automation with a human touch, we are not mainly talking about the loss of jobs and other. That's the totally different topic. Here, what we are referring to is when we do the automation, people should be able to manage the technology. So there has, if in case the technology there is a problem, should the are the people, can the people take over it? Is there a manual system where they can switch over? So that is very important. So technology should be user friendly, and it should always consider the human aspect. So I'll discuss one case study, and this is the case study of Boeing 737. So Boeing launched this 737 aircraft, 737 MAX aircraft in the year May 2017. So the main purpose they launched this was one main factor was to bring down the fuel efficiency. And what happened is, and they also came out with an engine called as LEAP 1B engine. So this was this engine was slightly larger in size, and they had to do a lot of design modifications to accommodate this engine. So what happened is, within a very short time, in October 2018, the first aircraft, the Lion Air flight 610, it crashed immediately after takeoff. Very, hardly 10 minutes, it crashed, and that was due to the software MCAS. They had a software, and there was a malfunctioning of the software, and that led to the crash. All people died. Then again, at that time, they dismissed it as probably could be a pilot error. But again, very shortly in March 2019, the second aircraft, Ethiopian Airlines Flight 302, crashed. Again, the same problem. So it took off, and within 7 minutes, it crashed. 127 people lost their lives. So when the study was done, why it happened, then after the second, the the regulatory authorities, they decided to ground all their throughout globally. There were so many aircrafts were there. All the aircrafts were grounded. No further clearance was given. So they did all the studies. Everything happened, and what they found out was the Boeing, they wanted to accelerate the aircraft deployment because they wanted to bring their aircraft into the market very fast. And in that process, they compromised on the pilot training cost. So they minimized the pilot training cost, and they thought pilots will be able to handle any other aircraft, so they will be able to handle this also. That was an assumption, and what was neglected was the comprehensive stakeholder training. Any technology, when it is launched, a new technology, definitely all the stakeholders must be identified and everybody must be made familiar with the technology. So that stakeholder training was not given, and there was a lack of transparency, safety communication, what safety things could go wrong. All these things were not made explicit. So the main root cause was the malfunctioning of the MCA. The MCA is basically, it was the maneuvering characteristics augmentation system, and that had to take input from two sensors. But what actually they did is they took only one sensor control. See, such a critical application where the reliability has to be very high, but they compromised on that and they took only one sensor, and that sensor incidentally failed. So it gave a wrong signal, and because of that, the software that it was trying to the nose got downward. Nose went into a downward direction. The pilots didn't know what to do. They knew it was the weather is clear, everything is clear, they have to take off, but nothing could be done. The software is pushing, and crashed into the sea. That's what happened. So the lesson is automation is fine because we have to embrace automation. There is no escaping that we need automation. But the thing is, automation must be done without adequate, if it is done without adequate human oversight and training, the results can be catastrophic, as we have seen with the case of Boeing 737 MAX. So this is what happened. They have two sensors, which is called as a angle of attack sensors. They took input only from one sensor. So that is why what we need is a systems thinking approach. So systems thinking means we don't look at it in isolation. Everything when we think of any technology, look at it from different aspects. Does it have an impact on the economy? Economically, what impact it will have? And what about the social impact? And social means then what about the people? Does it impact the people? Then look at the business. And again, the interactions between all these things. So all these things we need to analyze. It is not just a solution for just one problem, but it shouldn't cause a problem elsewhere. Especially as Mr. Balaya was talking, energy conservation, energy efficiency, and all those things. When we are focusing on that, it should not lead to another process problem. So energy efficiency is absolutely the need of the hour. But at the same time, we need to suppose the operation person, their focus will be mainly on the production efficiency. They will say, no, don't come with modifications of the equipments. We are happy with the new ones. But that is their concern. So we need to address their concerns and then introduce an energy efficient equipment. So systems thinking is the need of the hour. So when we, in engineering especially, when we do the design, at that stage itself, we need to think who is going to be the user, whether they can be, how they will use it, and then what are the problems they will face. All these things they need to think. And can it be implemented? Can it be serviced? So today we call it as a design for reliability, design for maintenance, design for servicing. So all these things have to be taken up at the early stage, because at that stage itself, if it is taken care of, then the rest is going to be easier. Later on, changes will be very, very costly. So systems thinking approach is like taking a drone's view. We are not looking at one single area, but at the entire, we are taking a complete perspective. Especially today, one of the major thing that, major area where training is required, engineers, we are having a lot of knowledge, but in project execution, in project management, project execution, people need a lot of training. So because we all do projects, And but if people learn about the project management techniques, the way projects are delivered will be much better. So project management talks about a drone's view, a systems thinking, not just think about the scope, but when you think about scope, also think about the cost. When you think about cost, think about the schedule. When you think about schedule, what about the quality? Are you compromising on quality? What about the risk? So like this, we need to look at the entire and not just at one. We are not just a safety engineer or a quality engineer, but an engineer with a holistic view, a systems approach view, and design thinking also. The design has to, we need to take care of the customer, the end user. We have to empathize with them. And that's what the design thinking concept says. So define the problem. What is their problem? We need to understand the problem, generate plenty of ideas, and then come out to the prototype, test that prototype, and then launch. So directly rushing to the product is not the right solution. So today we are talking about technology and all the other things. We have this Mumbai Dabbawalas. They are the concept of low tech, high touch. Today in agile project management, that emphasizes on low tech, high touch tools. So low tech, very low on technology, but high touch tools. You can use all the new technologies, everything. But for project management, Agile recommends a low tech, high touch. You use a whiteboard, just write the progress. What work I did today? What is pending? So these are all called as a low tech, high touch, and that is what our Mumbai Dabbawala they demonstrate, that they're carrying the tiffin box from one end to another, lakhs and lakhs of transactions, not a single tiffin box getting mixed up. The vegetarian should not go to non-vegetarian. The non-vegetarian should not go to vegetarian. It should come back on the right time. It should be delivered. Everything happens in the most sustainable way. They do not use any power consuming equipment. They use the Mumbai's crowded electric train. That's what the model. So we have a huge lesson to learn from the Mumbai Dabbawalas. Talking about the technology, use their principles. They have got Six Sigma, they have got ISO certification. They didn't apply. The certification companies honored them with all this certification. So project management, when I say, it is the entire sphere, starting from initiation to closing, every single area, people have to be trained. So people trained in the sense, in the professional way. So if they learn that project management, definitely the way they do it will be much professional. So even in the case of closing, just imagine Usain Bolt running a 100-meter, 200-meter race and just stopping short of the finish line. So then all the effort that he has done will not be recognized unless he crosses the line. So what happens in projects is we do all the work, but at the end, when the project is nearing completion, the team is demobilized, people do not know what is pending. So that should not happen. It has to have a closure. Everything has to be closed. The defects have to be completed. All the bills have to be settled. All the spares, if they have to be handle the spares. So nothing should be left out. So closing, 100% closing should be there. So that is one of the important things that by learning the project management techniques, we can bring a degree of excellence and professionalism into our projects. And just I want to leave with just one single thought. Today, all our engineering are for solving the problem of the people. So for people, we want to upgrade the people. The technology is mainly used for our sustainability and then bringing up the people. So in this picture, if you can see here, there is the ladder is given for the person to come up to the next level, but he is not aware that this ladder is for elevating him to the next level. What he does is without awareness, he is using that ladder, the rungs of the ladder as a fuel for his fire. So he's still on the old ways, doesn't know what to do with the ladder. So today, technology is there, but are we empowering the people with the technology? Are we giving them the right training? Are we giving them the awareness? That is very important, so that they can integrate seamlessly into the and adapt and embrace all the technology. So the way forward is automation is going to be there. Plenty of automation we are going to see, or AI. So we have to automate with the human face. Commit to growth. We need to learn, because training is very important. Continuous learning, training, and staying updated. If you are not updated, definitely we will be left far behind. Build network. We have to collaborate. Again, Mr. Ganesh was also talking about the collaboration. So today's context is not working in isolation. collaboration and contribution is much important. So that's why forums like this collaborate. So be a part of as many associations as possible. Plant engineers, project management. So all these things, when you are collaborating, you also contribute. So you find out what is your area, you can contribute, and together everybody can create a better world. So we no compromising on standards, because all the standards we need to follow. Safety, ethics, and sustainability should be the focus. And when we are doing this, understanding the interconnections and anticipating, something, when you are doing good, there can be an unintended negative consequence elsewhere. We have to be very much aware of this. We have to prevent this by proper design thinking, proper systems thinking, and automation with the human face, right, or a human touch, right. So thank you so much for your the opportunity and the chance given to me. Thank you so much.
Yeah, thank you so much, sir. Sunathan sir, thank you so much.
Thank
You
you.
almost all the concepts you have covered, and it's a very much information important for engineers to adopt. See, adaptability and system thinking is something we should follow. Because design for manufacturability alone we are targeting. So your example about Boeing also is very much enlightening us, because normally what we do is we only manufacture and supply. Training part you have rightly pointed out where they failed. So that's a very good thing, sir. Thank you so much.
Thank you, sir.
I request next panelist, Mr. Eriko from Singapore. I think currently he is camping at Kuala Lumpur. Please join us, sir.
Hi, thank you, Engineer Prakash. First of all, thank you very much to IIP for this excellent opportunity. So it's not just to share, but also, it's also an opportunity to learn from the other panelists. So you can see that this evening, a lot of the common focus is really on sustainability. You see, all the panelists have mentioned something on sustainability, the importance of this, right? So today I'm just going to touch on briefly on the adopting of standards in engineering practice, right? Next slide, please. Okay, so I'm just going to cover very briefly on these 4 points: standards in a changing world, value of standards to the engineering professional, understanding standards, and finally getting involved in standardization. I'm also going to talk a little bit on the challenges facing standardization, right? Okay, next slide, please. Okay, can you move on? One more slide. Okay, we are talking about this, currently in the very different world. I mean, where the rapid emergence of technologies, areas like AI, additive manufacturing, UAS, UAV, or you call that simply drones, and even cybersecurity, which was previously mentioned by one of the panelists, right? In view of all this emergence of technologies always play catching up in terms of standards development, because technologies always be at the forefront while standards will take time to be developed. So when we are talking about standards in this context, we are also covering codes, specifications, recommended practices. Sometimes they call it bulletins, right? So there are many terms that standards developing organizations term their document. So we will broadly term this as standards, right? So if you go online, there will be some arguments saying, oh, standards means this, specification means that, but we broadly term this as standards, right? Okay, another issue is that, climate change, sustainability development, all this falls under the UN sustainability development goals. Right. In fact, if you notice some of the management system standards, Right now, they have actually incorporated climate change as one of the requirements. So things like that are actually transforming standardization as well. So sustainability is going to be a very, very important area where standards are concerned, whether it's technical standards or other related standards. And obviously globalization, because we are now in the connected world, in terms of economies, culture, and trade, right? Everything are interlinked. So all these are really transforming the standards world. Okay, next slide, please. Okay, so what is the value of standards when you talk about? I mean, obviously, standards can relate to not just technical people. There are other standards for accounting and all those things. But over here, we are talking about what does standard means to an engineering professional. Could be an engineer, could be a technician, could be an inspector, right? So in terms of products, we always talk about standards will help in terms of reliability, quality, efficiency, and most importantly, if you look at that, it's all written in uppercase, safety. In fact, the most important reason for standardization and the value is actually safety. It promotes safety and consistency, and some of these codes and standards are actually transformed into regulatory compliance. It's global everywhere, where even if you talk about regional standards, European Union, or even local standards, you have a code of practices. These are more or less, some of these are actually translate into regulatory requirements, right? For example, pressure equipment, pressure vessels. So in India, I'm sure there are specific requirements that goes back to the codes and standards, right? And standards are actually not just proven practices. In fact, they also learn from, for example, accidents. So standards are dynamic. They are not just a one-time thing and finish. It's like R&D. Every few years you revise based on the emergence of technology, based on accidents, based on lessons learned. So all these things create value in terms of for the engineer, for the technician, for the inspector. Right? Shall we? Next slide. Okay. Understanding standards. Right. Just like our previous panelist, engineer Viswanathan mentioned, he focused a lot on talking about training. So in fact, when you talk about training today on standards, where you can actually take up training from the SDOs. SDOs means standards developing organizations. All this, they have different kinds of standards. And one thing to emphasize here is that standards do not exist, does not work in solo mode. An engineer probably need mastery in various standards, even for a single product, right? So, SDOs can mean ISO, which everyone should be very familiar, IEC, and IEC is actually having its conference in India this week for the year, and IEEE, ASME, API, ASTM, AWS, BSI, and not forgetting BIS, Bureau of Indian Standards. So there are so many, right? Each of them, they have certain kind of focus, right? But the challenge today is that for engineers, you are not just required to know just one standard from a single SDO. You probably need to have certain level of knowledge across a suite of standards, right? And another way to learn about it is through practical applications. While in the work, you learn how standards are being applied in day-to-day manufacturing, project management, testing and calibration, stuff like that, right? And obviously, one of the challenges for standards is interpretations. Most of us do not read standards are not they are not like storybooks or novels that you reach from page 1 to page 100, right? So typically you only pull out requirements, a specific paragraph that you need for your project or your product, right? So sometimes interpretations come in very important because you're not sure whether are you reading it, are you interpreting it correctly, or is it the other way around? So who is in the best position to interpret this? So I mean, despite of you see a lot of a lot of posting on LinkedIn, people trying to interpret standard clauses, but in reality, only interpretations issued by the SDOs are considered valid. So so those online could be true, could be fake as well, right? This is for interpretations, and obviously learning standards. It could be also like interest group. You form interest groups to actually study standards, to learn from your peers, professional societies like ASME, API, and IEEE. They also offer a platform for engineers to actually learn about standards and its applications and experience of implementing them, right? And obviously standards development groups. So these are various platforms that engineers today can actually take on to learn about standards in this changing world. Right. Next, please. Next slide, please. Okay, so one of the things that is very important is getting involved in standardization. So this is the one of the ways to really learn about standards. And standardization is a no-ending journey that you need a lot of continual flow of expertise to come into it to actually contribute and continue to develop the standards. So obviously there are some important benefits that when you involve in standardization. And by the way, India has some of the biggest standards development groups in terms of ASME. We have India it's called India Review Group, IRG, which has a huge number of professionals involved. So coming back to the benefits of getting involved in standardization work is, you get very early access to what's going to happen. What is the trend? What is going to happen in the next edition? Early access to the draft of standard specification, best practices, and the other thing will be, the opportunity to learn from the best in the business. When you talk about the best, it's not just domestic. We are talking about global experts. So this is an opportunity, especially for young engineers, to start early, to get involved in standardization, and take the opportunity to learn from world-class experts. And obviously, when you are involved in standardization work, you have the ability to influence, right? So this also makes sense. I mean, even if you are an engineer, but you have business development responsibilities. So these are the things that you can take on to influence standards making, right? So this is pretty beneficial, not just for the individual, but also for the employer, for the business as well, right? And finally, definitely, it helps in professional profile enhancement. So you are sitting in the committee, you are taking on this role to contribute to standards development work, right? And obviously, the most important thing here is contributing to a safer world, which is the key reason for all this development of technical standards. The essential purpose is safety, right? So before I end this, I mean, there are also challenges facing the standards, right? For example, in general, a lot of employers in our part of the world, they tend to think that young graduates coming out from the universities, they generally lack standards knowledge, right? Because these are typically not covered in the studies, in the course, right? So this is one of the challenge that, when they come up, they do not have this information, do not have this background. So employees have to really get into it, to send them for training, to let them understand what is this. They might have fundamentals in engineering, but standardization becomes very important, because today a lot of products, processes, management systems are all linked to standards, and it's not really those things that you learn from the universities. So this is a key challenge facing a lot of organizations. Recently, I spoke to someone in the US. He was saying the same thing, like standards education is very lacking. I'm not sure the case in India, but definitely it seems to be, standards education is very important for future engineers and professionals. All right, so I keep this very short. So, but of course, this is something like a standards 101 presentation, very basic. But of course, there are so much more involved, right? So I look forward to your feedback. Thank you.
Thank you so much, Mr. Eric.
Yep.
I know you are very much involved in the ASME standards and all, and as normally it's referred, 140 years ago, they started the standardization because of the accident in the boilers. So in production of steam, that's the initial reason for standardization. And you have covered mostly how to get involved in the standardization. That's very important. And what you said is a dynamic. The standardization is dynamic. That's very much important. So unless you are there in the committee involved in the standardization and you develop groups, it cannot happen. So you are also in the groups. I know very much. You have been the chair of ASME in Singapore. I know you have been pretty in the groups at other places.
So, Engineer Prakash,
I
just want to add on. Sometimes getting involved in standardization is so it could be you really need enthusiasm and passion, right? Because a lot of times people involved in standardization, they join with some enthusiasm, but they could not last. They need resilience, right? Yeah, so in the States, for example, in ASME, I attended some of the standards meeting in the States. You see people contributing for 40 years. Today, they go into the standards meeting with walking sticks, but they still make it a point. Probably not so much because of money, but for the passion and to make it a safer world, right?
I would say they are visible gods, because those people only developed standards for safe environment and safe world. So that we should acknowledge. Definitely their contribution not visible. Mostly, as you said, is standardization, or the people are there. It's not visible. So definitely, I agree with your point. People coming with walking stick and the aged people, that passion. As you said, we should develop passion, and it's a message to all engineers that even though you spoke in the last, it was the very important point that how to adopt standardization is a very important aspect for all engineers today. So that you have given much focus. Thank you so much, Mr. Eric, for your valuable time, and late evening you joined us. Even though we are almost 8 o'clock, you are past 11, I think. No, so
no worries.
Thank you so much. Thank you so much.
Thank you.
We'll so just any other points other panelists want to give, they can just come in, and a few points you can point out.
Hey, Prakash, I'll say already one Mr. Balachandra has raised the hand, and there are 2 questions in the Q&A. Let us address that. because
Okay, I'll sum up. Then we'll go for question answer. That will be okay. So we
Yeah.
have covered most of the points. Just I'll with the share the screen. So I want to sum up. IIP is fully aware and committed that engineers have professional obligation to safeguard life, health, wealth of public and protect environment. So mostly our engineer Ganesh has covered the safety aspects and other aspects. And we also believe in the engineers need professional development regardless of the engineering specialization. That is, Mr. Viswanathan has already told about the basic requirement of the training. And mostly engineers are into independent practice, as well as vast majority of our engineers work in large public and private hierarchical organization or an MSME. So that's we have to follow. That's let us all commit to work for the safe and sustainable world. This is the message we carry today, irrespective of the field we work. Let us carry this message. Thank you so much, and we'll go for the